All right, fantastic. Let's go on to some other things here. Let's see. Now, those two metals, we knew what they were. We could look up their specific heat in a table, but what if we don't know the heat capacity of the metal? Like this metal right here, which I think is zinc. At least that's what it said on the internet when I took it. If we don't know if it's zinc for sure, one of the best ways to tell if it's zinc is to actually measure its heat capacity and then go compare it to the one in the book. So we can use the calorimeter to measure the specific heat, that C value, that capital C. We're going to be able to use a calorimeter to figure it out. So what is a calorimeter? A calorimeter is a piece of lab equipment that is used to measure the heat that's either absorbed or given off by an object. And I've got a couple of them here. There's this fancier one on the left and there's this styrofoam cup one on the right. Any guess which of the two we actually are going to use in our experiment in a minute? Well, you're right if you guessed the styrofoam cup. We do not have one of these. This is called a bomb calorimeter, and we don't have one of those. What a bomb calorimeter is used for, it's exactly the same approach as this one over here, but it can be used with different materials. But all calorimeters are used to measure the energy absorbed or giving off by an object, and they're called calorimeters for a reason. Like, for instance, they use these things to measure the amount of calories in food. So if they say in one of those small M&M packs there are 88 calories, the way they learn that is using a calorimeter. Because a calorie is a type of unit of heat measure just like the kilojoule. It's just a different unit of heat. So a calorimeter can be used to measure the amount of heat or energy that you can gain from these candies. So that's what the one on the left is for. Now we're going to use the one on the right. And the reason is because that's what I have at home. And as a matter of fact, we're not even going to use a styrofoam cup. A styrofoam cup is better because it doesn't let the heat escape. It's an insulator. But we're just going to use a plain old beaker. But this is what it's going to look like. And so if we're going to figure out how this is to measure the specific heat of the metal, what we're going to do is we're going to take our calorimeter, we're going to fill it with some water. That's what my blue stuff is meant to represent. And we're going to throw that piece of metal in there. Now, if we make the piece of metal hot before we throw it in there, then that water will warm up in temperature as it absorbs that heat. And that exchange of heat in the calorimeter is what we're going to use to measure the specific heat of the metal. So we don't need to do copper because we already know that one, right? We saw aluminum in the previous example. But I want to add to this table, I want to add zinc. And I don't know its specific heat, its C value. So let's figure out how we would do that with a calorimeter. Well, there's a strategy, and what I'm talking about is not just the lab strategy, because you're going to see me do this in the kitchen in a second. But I'm talking about on paper. How do we figure out what that C value is? Well, if we can measure the heat gained by the water, because all this heat is going to be radiating out into the water. Obviously, the water's temperature is going to go up. Well, if we can measure that, we might be able to measure how much heat gets absorbed by the water. All the heat that gets absorbed by the water must have been released from the block. If the heat was leaving the block, it has to be the same heat that went into the water. So if we can measure the heat gained by the water, we will know the amount of heat lost by the block. As a matter of fact, if I were going to say it right now, if I wanted to give a sign to the heat gained by the water, would you say that's positive or negative? Well, I think it's going to be positive because it's gaining that heat. And the heat lost by the block will be negative because it's going out of the block. But these should be the same, right? If this is 100 joules of heat gained by the water, it obviously came from the block, so it would be 100 joules lost by the block.